The topic of this lesson is using mean to evaluate spending. Example 1. Elena knows that her morning cup of coffee is most definitely a discretionary expense. She pays $2.75 for a 9-ounce cup of coffee and was wondering if that is a typical price. On Monday, she asked 6 of her coworkers what they paid for a 9-ounce cup of coffee. Their costs per cup were $2.85, $2.15, $1.95, $3, $2.05, and $2.40. How can Elena compare her expense with those of her coworkers? What if I find the mean? Elena can use the mean or average to compare her expense to that of her coworkers. To find the mean of the cups of coffee, Elena will need to add all of the cost for each of her coworkers, 285 plus 215 plus 195 plus $3 plus $2.05 plus $2.40, and then divide by the number of coworkers she asked, which was 6. When she adds the numerator, the 285, 215, 195, $3, $2.05, and $2.40, she gets $14.40. She will then divide that by 6, the number of coworkers, giving her the mean of the cup of coffees as $2.40. So what does this mean? Am I spending too much? Yes, I spend $2.75, which is 35 cents above the average. This will add up after a while. I should find a more affordable coffee. Now it's your turn to give it a try. Let's try this. Nora is a college student. She needs to make an essential textbook purchase for one of her classes. She researches the cost of the book at her college bookstore, some local booksellers, and some online merchants. The prices per book are $128, $118, $96, $102, $118, $118, and $102. Find the mean of the textbook prices. All right, so I want to introduce to you here a new type of notation or way of writing things. We're going to be writing the mean in a more compact way using something called sigma notation. I'm going to show you what it is, I'm going to tell you what each of the pieces are, and then I'm going to explain to you how it works through an example. So what you see here on the screen, this is sigma notation for the mean. The first part that you see is an X with a line across the top. This is said X bar, and this simply means the mean. So when you see an X with a line across the top, you will say either X bar or say the mean. Now what you see in the center of this notation, it looks kind of like a funny E. This actually is the Greek letter sigma, and in mathematics it means to find the sum or to add. Anything that follows that sigma, you will add those things to each other. Now to the right of the sigma, we have an X with the subscript I. This is read as X sub I, and this is referred to as subscript notation. Each data point in our data set will be represented by an X sub I. In Elena's data set, she asked 6 coworkers what their price was for their cup of coffee. Each coworker would have an X sub I. One coworker would be X sub 1, another coworker would be X sub 2, and so on. Each data point would get their own. The I at the bottom here is representing the index, and this just tells us which of the coworkers, in Elena's case, are being added, or in general, which data points are being added together. Then we have the n, and this just tells us how many terms were added together, right? And in the terms of the mean, we will always divide by this number, which is why we see this 1 divided by the number of terms. We're going to practice using sigma notation by using example 1. We're going to use the information from example 1 to represent the formula for the mean using a compact notation. Now, if you remember before, Elena was trying to determine whether or not her $2.75 was too much or just right for a cup of coffee. So she asked 6 coworkers, and then she found the mean. So we're going to do that problem again, but instead of actually finding the mean and writing it out, we're going to put it in compact notation. The first thing we're going to need to do is we're going to need to identify how many data points Elena has and label them as X sub i's. We're going to call the $2.85 X sub 1, the $2.15 X sub 2, the $1.95 X sub 3, the $3 cup of coffee X sub 4, the $2.05 cup of coffee X sub 5, and the $2.40 cup of coffee X sub 6. Now note, these just tell us that we have 6 different people who told us their price for their cup of coffee, and each of them is represented by a data point X sub something. Now we are finding the mean, so X sub bar is equal to the sum of all of our X sub i's, starting with the first X sub I all the way to the 6th X sub I. Now, remember, when we find the mean, we have to add all of those data points. That's what we see over here with the sigma notation. But then we have to divide by the number of data points we added. So in mathematics, we like to show that division by using the fraction version of that division. So we have added 6 data points together, so we will then write 1/6, which in this case just means divide that sum by 6. If we were to read this aloud, we would say, the mean is equal to 1/6 the sum of X sub I from 1 to 6. And just like before, this would equal $2.40. All right, now it's your turn to try. Let's try this. Addie's monthly water bills for last year are $27, $31, $30, $26, $25, $27, $37, $33, $32, $28, $26, and $26. Express the formula for the mean using sigma notation and calculate the mean water bill for the year. Now it's time for some additional practice. Go ahead, find your financial algebra textbook, complete textbook page 12, numbers 6 through 12, submit your work on Canvas. This should take you about 20 minutes. If you need any extra help, feel free to reach out.